Hi everyone, I am Sneha, co-founder and CEO devCompass.ai. Welcome back. We are at video 3 for stage 1 of the course, and I hope everyone who is following along is already aware of this and you have watched all the previous videos. I hope you're enjoying the course and you are doing your assignments well. For those who really don't know what this course is about, please head over to devcompass.ai and you will get all the relevant information. Today's video is going to be about the context window. I think one of my favorite areas to talk about, especially for the curious ones who keep hitting that token limit for the week, for the day, because you're just sitting with Claude all day. I think you are going to have fun. We introduced the context window back in stage 0, very little. I described it as Claude's working memory. Now we're going to dive deeper because you've already watched the agentic loop video and you can see something you couldn't see before then, because we have seen how every interaction kind of increases and adds a block and how that fills up the whole context. Every turn of the loop is adding to the context. Like I said, the system prompt is there, conversation history is there, every tool call gets added, every tool result gets added. So the thing fills up really fast, and when it does, things go wrong in specific predictable ways, and most people call it that AI has started hallucinating. So this video is about understanding that constraint clearly enough that you can design around it, and the solutions around it would come later in stage 5 of the course. We're taking it slow, we're taking it simple for us to have a very deep understanding of what all of this is about, so that we can answer the exam questions pretty well. And this is just building your mental model, so that when we reach stage 5, and I hope all of you do, it makes more sense when we get there, right? Okay, so you have seen this in stage 0, same diagram, the whole context window being a box, same outer box, same 4 inner blocks. And I really want you to recall it quickly and then notice that one thing we have added new here. So the 4 blocks, system prompt, conversation history, tool results, documents, context, everything is the same. The new element is the token gauge in the corner. Right now it's partially filled, about 40% in this diagram. That represents the context being used. The point of showing this gauge at 40% now is so that when we fill it up in the next few slides, the contrast should be very clear. Let's take a rough intuition of tokens. Around 750 words equals about 1000 tokens. Claude Sonnet's context window is around 200,000 tokens. That sounds like a lot, and it is until you're running a long agentic session. And let's look at what actually flips it up. Slides. Okay, that's it. So before we actually look at what fills the context window, let me give you the one number you need for rough intuition about scale. Look at this card on the screen. 1 token is roughly 3/4 of a word in English. So if you want to think in words, 750 words is approximately 1000 tokens. Look at the sentence I have broken into tokens in the example. The customer wanted a refund, 8 rough token segments, each bracket representing 1 token. That's how finally the text gets divided. Now the 3 scale references lines below the example, 750 words, 1000 tokens, that's your conversion rate. A full novel, something like 80,000 to 100,000 words, is roughly 100,000 tokens. Claude Sonnet's context window is approximately 200,000 tokens, so the context window is roughly 2 full novels worth of text. That sounds enormous, and for a short conversation it is. You will barely touch that context window. The problem emerges when you're running a long agentic session with large tool results, or when you're injecting documents, or when the conversation has 40 turns. Those cases eat through those 200,000 tokens faster than you expect. The next slide will show you what exactly consuming the space. Okay, let's see. Look at this box filling up on screen. This is the context window, and I want you to like walk through each section from the bottom up, because that's the order in which they consume space. At the lowest, at the very bottom, there's system prompt. This is a fixed cost. It's there every single API call from the first turn to the last. A typical system prompt is somewhere between 500 to 2000 tokens, not huge, but it's always there. Above that, conversation history. This is a variable cost. And do you know why? Yes, because every time there's a tool call, we did talk about how that response gets added to the user's message and conversation history as well, right? So Claude's response will add tokens, roughly 200 to 500 tokens per turn, depending on how verbose the messages are. At 20 turns, that's potentially 10,000 tokens just from conversation history. Above that, tool results. This is where things get unpredictable. A successful tool result that returns a single value like order shipped April 3rd, and you need context from the previous videos to actually understand the reference I'm giving here. It might be 20 tokens. A tool result that returns a full customer record, name, address, email, order history, account status, preferences could be 2000 tokens. Every tool call in the conversation adds its result to the history. Multiple large tool calls compound very quickly. At the top, documents and injected context. If you are passing a PDF, a policy document, a code file, a large customer record in the context, these can dominate everything else. A 20-page policy document might be 8,000 to 10,000 tokens on its own. Inject 2 or 3 of those and you have consumed a significant portion of your context before the conversation even starts. And then look at the remaining empty space at top of the box. That's the remaining capacity. It's smaller than you would expect. That's the point of this diagram. The context window feels enormous in the abstract, but an agent that's been running for 20 turns, calling tools that return medium-sized results with a reasonable system prompt, that agent has used a substantial portion of its context before anything goes wrong. Now, let's look at the practical consequence of that filling up. Okay, look at the two cards side by side, before and after a long conversation. Okay, so turn 3, by that time, that's like early in the conversation, the context window is mostly empty. There's system prompt that sits at the bottom, prominent, clearly taking a proportional amount of the space. Claude's attention, shown as the spotlight coming from the Claude icon, points clearly and directly at the system prompt. Instructions followed precisely. Claude is operating exactly as you would have designed and whatever you expect out of it. In the right card, which is turn 28, like late in the conversation, the context window is now full. The system prompt is still there, but look at where it is. It is at the very bottom of a very packed stack. 25 turns of conversation history, tool calls, tool results, possibly some documents, all of it sitting on top of the system prompt, pushing it towards the bottom of the context. And Claude's attention, shown now as multiple scattered beams instead of one clear spotlight, is diffuse. It's not focusing cleanly on anything. Instructions that Claude followed precisely in turn 3 are now being followed inconsistently in turn 28. This is called lost in the middle problem. Claude's attention isn't uniformly distributed across everything in its context window. Content at the very beginning and very end of the context tends to get more attention than content in the middle. And in a long agentic conversation, your system prompt, your instructions end up being buried in the middle under these layers of history. They are still there. They have not disappeared, but They are very less focused. Claude can still see them technically, but it's processing them less reliably than it would have done in 3 turns. So we are going to solve this problem properly in stage 5 with specific techniques. For now, I want you to have the problem in your mental model, named very concrete and tied to a visual you will recognize when we come back to it. Lost in the middle problem. It is that. Okay, next up. So, what do you do about this right now at stage 1? If stage 5 is the solution, do we skip to stage 5? No. There are persistent case facts, blocks, context compaction, scratch-pad files, etc., very jargony terms. But there's one instinct you should build immediately, and it's on screen. Return only what and it's on screen. Return only what Claude needs. That's the rule. Look at the 3 bullet points on the card. First, filter tool results before they enter the context. If your database query returns 50 fields, but Claude only needs 5 of them to answer the user's question, filter it. Write a function that extracts those 5 fields before you append the result to the conversation history. The other 45 fields never enter the context at all. Second, don't dump full records. Extract relevant fields. If getCustomer returns the full customer object, address, phone, email, account history, preferences, billing information, date of birth, but all Claude needs right now is the customer ID and account status, return just those 2. Same tool call but much leaner result. Third, every unnecessary token is capacity that you can't get back. This is the constraint. The context window doesn't reset mid-conversation. Every token you put in stays it until the conversation ends, or you explicitly manage it. Bloated tool results are tokens you can't use for something else. The caption at the bottom, which is context is a resource, treat it like one, has to be your new mantra. So we set this in stage 0 and we're reinforcing it here with a concrete mechanism that please filter your tool results. You have 3 foundations of stage 1. What an agent is, Claude plus tools plus a loop that knows when to stop. How the loop works, the 5 steps, the stop reason as the gatekeeper, the 2-way it breaks, and what the context window actually means, when an agent is running, what fills it, how, etc. And your walkthroughs are what is going to turn this into a skill. You're going to read a conversation log, find every step of the loop in it. You're going to diagnose 3 loop implementation, identify what's broken. It is something that will be your stage 1 capstone, and the reflection question at the end asks what would break in production. So pay attention to whatever you write there as answers, because that exactly what stage 2 is going to fix. Go do the walkthroughs. I will see you in stage 2. Thank you so much for watching.